What's good, Logan? So coming at you with a video on how to solve radical equations and inequalities. A couple of things going on. We're going to be taking a look at inequalities. So this is the inequality technique. I got two steps that I want you guys to follow. First step, number one, solve the inequality. So you guys are going to be solving the inequality just like you've been doing equations. The second step, though, is something that's going to be a little bit different. We're going to check the radicand. Now, this idea of checking the radicand is going to add a slight different flavor to the problem. When I say check the radicand, what I mean is that the radicand in some circumstances has limitations. So when it's a square root, the radicand must be greater than or equal to 0. And we'll get back to that when we see some example questions. All right, so let's just jump straight into it. Question number 1, solve 3 square root of x minus 2 is less than or equal to 15. So what we're going to do here is we're going to solve it like we would solve any equation, any radical equation. We're going to divide both sides by 3. We're going to isolate the radical. Dividing both sides by 3 gets rid of the 3 and gets the radical by itself. So we have the square root of x minus 2 is less than or equal to 5. And then we solve it by getting rid of the radical. We're going to square the left side to get rid of the square root. And we're going to square the right side to balance it out. This is going to give us x minus 2 is less than or equal to 25. The last thing we're going to do is we're going to add 2 to both sides of the equation, the inequality, sorry, and this is going to give us x is less than or equal to 27. Now, under most circumstances, we would be done, except radicals have very special circumstances, have very special things that can happen with them, primarily the domain restrictions. So radicals cannot have radicands, or square roots, sorry, not just radicals, but square roots can't have numbers that are negative inside the radical. So we're going to stipulate, we're going to create that exception right now. So we're going to say when there's a square root that the radicand cannot be negative. In other words, the radicand must be greater than or equal to 0. Now in this problem, the radicand happens to be x minus 2. So we're going to take the x minus 2 and we're going to replace it with the word radicand. So the x minus 2, also known as the radicand, must be greater than or equal to 0. We solve this inequality and we find out that x has to be greater than or equal to 2. So our solution to the equation is x is less than or equal to 27. But our radicand stipulates that we cannot have numbers that are less than 2. We must have values that are greater than 2. So as long as our answers are greater than 2 and less than 27, we'll be okay. So our solution is going to be all the x values that lie between 27 and 2. Now it's allowed to equal 2 and it's allowed to equal 27 because in our solving, it said that it could equal it. So our final answer is going to be that 2 is less than or equal to x is less than or equal to 27. Or in other words, x lies between the values 2 and 27, including the points 2 and 27. All right, so let's try this again. Remember, there are 2 steps. Step number 1, we're going to solve it. Step number 2, we're going to make sure that the solutions all are satisfied by the radical. Let's try it one more time. We're going to add 6 to both sides with question number 2. This is going to give us the 2 square root of x is greater than 14. Next, we're going to divide both sides of our inequality by 2. This is going to give us that the square root of x must be greater than 7. We're going to go ahead and square both sides, and this tells us that x is greater than 49. So as long as x is greater than 49, this inequality will be satisfied, but we must check the radicand. Now, this is a square root, and in square roots, the radicand must be greater than or equal to 0. Remember, you cannot have negatives inside of a square root, so the radicand must be greater than or equal to 0. Now, the radicand in this problem happens to be just x, so we're going to change the word radicand to the x value, and we're going to say that x is greater than or equal to 0. As long as our solutions are greater than or equal to 0, we're okay. Now, since our solutions are greater than 49, all of those are greater than or equal to 0, so we're just going to say the answer is x is greater than 49. In other words, it's all the numbers starting at 49 and that go off to infinity. So we can either write our answer in set notation or we can write it in interval notation. Let's take a look at one more example. Our next problem, we have 4 times the cube root of x minus 5 is less than 12. So we solve it like we've been solving all the equations. Step 1, solve it. Divide both sides of the equation by 4. This gives us the the cube root of x minus 5 is less than 3. We have to cube both sides of the equation to get rid of the cube root, and we are left with x minus 5 is less than 27. Adding 5 to both sides of the equation, we find out that x is less than 32. Now, once you've solved it, the second part is to make sure that the radicand is satisfied. But when you're dealing with odd roots, the radicand can be anything. There are no restrictions. So in this case, the solution is just x is less than 32 because in cube roots, there are no restrictions. So if you have to break this down into a simple idea, it's that if it's a square root, the radicand must be greater than or equal to 0. But if it's a cube root, the radicand has no restrictions, and your solution is just your solution. So in problem number 3, our answer is x is less than 32, or it's going to be all the numbers that are less than 32 from negative infinity all the way through 32. If you guys have any questions, please send me an email and I'll get back to you as soon as possible. Otherwise, I'll see you on Monday. Best of luck with this assignment.